All right, I wanted to go over some problems with those of you that might need a little bit more help and what we were going over last week on our check-in when we were dealing with these inscribed angles and central angles and angles around circles and that sort of thing. So just follow along and I'll go through all those problems that were on your last check-in, okay? So here it says solve for x, okay? Well, x is an inscribed angle, and I know that it's going to be 1/2 of the arc that it intercepts, okay? Well, I know that this arc over here is 160 degrees. I know that this arc down here is 136 degrees. And I know that altogether, all three of those need to add up to 360 because that's how many degrees there are in an entire circle. So if I add those two together, I get 296. And then if I take my 360 and subtract 296, I'm going to end up with 64. So that means that this arc over here is 64 degrees. And if that arc is 64 degrees, then this inscribed angle is going to be 1/2 of the 64. So it's going to be 32 degrees. Okay, hopefully that made sense. Let me move that over a little bit. There you go, so you can see some of the work. All right. Next, it says solve for x. Well, x is a central angle, and I know that it's going to be the same as the arc that it intercepts. So it says arc ADC. Remember, if it's three letters, it's a major arc, meaning it's more than 180 degrees. Okay, so this arc is more than 180 degrees. It's actually 300 degrees. So that means that this arc is going to be 60 degrees. And remember, central angles are the same as the arcs that they intercept. So if this is 60 degrees, then x is also going to be 60 degrees. Okay? All right. And in our next example, we've got another inscribed angle, okay? Well, I know that angle 2 is going to be 1/2 of the 128. The beautiful thing about a lot of these problems is that there's more ways than one to solve them. If I knew what angle 2 was, I know that these two are a linear pair and they would be supplementary. But let's just go with the theory that there's 360 degrees in a circle. So if I take the 360 minus 128, that's going to make this 232. Okay, and then if I divide that in half, that's what angle 1 is going to be. So 232 divided by 2 is going to make that 116 degrees. Okay, there you go. And then this angle over here, of course, would have to be 64 degrees because they're a linear pair. They would add up to 180, and 64 is 1/2 of 128. All right? Okay, let's look at our next example here. It says, find the measure of angle A. Let me zoom in on that a little bit. So find the measure of angle A. All right, well, there's a theorem that states that if a triangle is inscribed in a circle and one side is the diameter, then it's a right triangle. And that makes sense because remember, a semicircle is an arc that measures 180 degrees, and A would be 1/2 of that 180 degrees, so it'd be 90 degrees. So again, if a triangle is inscribed in a circle and one side of the triangle is the diameter, then it's going to be a 90-degree triangle, okay? So the measure of angle A is going to be 90 degrees, okay? Now the next problem asks us to find the measure of angle B, okay? Well, we know that angle A is 90 degrees. We know that angle C would be 1/2 of this arc that it intercepts, so this would be 35. So we know that angle C and angle B are going to be complementary. They're going to add up to 90 degrees. So if I wanted to find the measure of angle B, I would just take 90 minus 35, and that's going to make angle B be 55 degrees. Okay, so angle B is going to be 55 degrees. All right. Let's go on to our next one. Find the measure of angle B. All right. Well, first of all, we got a triangle here, and I know that this angle is 32. All right. Well, I know that this angle right here and this angle right here intercept the same arc. Well, if they intercept the same arc, then they must be congruent because remember, the angle is 1/2 the arc that it intercepts, and if they both intercept the same arc, which is 64 degrees, this one would have to be 32. I also know that these are vertical angles right here, so if this is 116, that's 116. So if I add the 116 plus the 32, that gives me 148, And I know that all three angles have to add up to be 180 degrees. So in order to find the measure of angle B, it's simply going to be 180 degrees minus the 148. So that's going to end up being 32 degrees. Okay? All right, we just got a couple more to go here. Here we've got a quadrilateral inscribed inside of a circle. And it says that measure MNP is 70 degrees. QMN is 94 degrees. And arc QP is 85 degrees. Okay? So if this is 70 degrees, then I know that this whole thing right here would be 140 degrees. Okay? And if I subtract 85 from 140, that makes this arc 55 degrees. Okay? And I'm trying to find MQP. All right? Well, if I knew what this arc measured, I could divide it in half, and that would give me MQP. All right? So I know that if this together is going to be 140, then I know this arc over here has got to be 220. Okay, guys? Granted, you could have also figured out that if you take the 140, just subtract it from 360, this is going to be 220. You didn't really have to add those two together. I was just illustrating to you how you could find that one missing measure. Okay, so half of 220 is going to be 110, and that's what angle Q over here is going to be, or angle MQP. It's going to be 110 degrees. Okay, guys? And then finally, it says to find the measure of angle C over here. All right? Well, again, if you've got a diameter that is a side of a triangle that's inscribed in a circle, then that's going to be a right triangle. Okay, guys? So that means that that's 90 degrees. So this and angle C are going to be complementary. So if I take the 90 minus the 28, that's going to give me my final answer, which is going to be 62 degrees. So angle C measures 62 degrees.